Okay, so we're going to review today the operations with mixed numbers. It's going to be vastly important for fifth grade, and I know you're going to see it in sixth grade. So let's review all of the operations, not just one. So let's start with addition. So we're going to add 3, yeah, 3 and 1/3 plus 2 and 1/2. And I started to write it up and down, but I want to show you this. Usually, when you see these problems, they're going to be written sideways. You could do it sideways, but that's really not going to help you that much. So, what I would recommend is go ahead and rewrite it up and down, because that's going to help you a lot more. So we're going to erase this because we're going to do some side work out here. So before we do anything, we're adding fractions. So we have to find a common denominator. And the common denominator in this case is going to be 6. And the reason that we know that is because 3 times 2 equals 6. But another reason that I know that is because 3 and 2 are both prime numbers. And that means that their only factors are 1 in themselves. So they don't have anything in common. You don't believe me? Work it out yourself or Google it. But I promise you, they're both prime factors. So 1/3, 3 times 2 is 6. So we do the top by 2, and 1 times 2 is 2. And then 1/2, we should know, is equivalent to 3 over 6. But if we don't, then that's okay. So now we're ready to add. We're going to keep our denominator of 6. And we're going to add our numerators. 2 plus 3 is 5. So we're done with our fraction part, because 5 over 6 is in simplest form, and we don't need to convert it to a mixed number. So we're just going to add our whole numbers. 3 plus 2 is 5. Now keep in mind that's 3 plus 2. I know that when we get up to 5th grade and we get in the higher grades, sometimes we want to say we're multiplying. But you're not always multiplying. I mean, we still do addition and we still do subtraction, even though that's what you see a lot more than anything is multiplication. So our answer, the 3 and 1/3 plus 2 and 1/2, is 5 and 5/6. Now you can make these mixed numbers and that's fine, or rather make these into improper fractions and that's fine. But you're just making more work on yourself, and I think it's unnecessary to do that. So let's see if we can find one to convert, because I think that that's the difficult part of the addition of mixed numbers. So if we have 5 and 2/5 plus 4 and 6/7. So these are some weird numbers. But the first thing that we need to do, we're written sideways. But what I would do is I would write this up and down. Because if not, then you're just making it harder on yourself. So I would write 4 and 6 over 7 right there. And then just because I erased it and I wrote it and I can easily erase it, I would go ahead and erase it. And so here we've got a problem now. Okay, so we're going to find a common denominator. And once again, our denominators are prime. So that means we multiply them together to find a common denominator. And when we multiply 5 and 7 together, we get 35. So 7 times 5 is 35. So we do the top by 5. 6 times 5 is 30. Okay, so here we do the bottom times 7. We do the top times 7. That's 14 over 35. So here we've got our really ugly numbers. So we keep the denominator here, which is 35, and then we add our numerators. 14 plus 30 is 44. And the reason I know that is because 4 plus 0 is 4, and 1 plus 3 is 4. So now we add our whole numbers. 5 plus 4 is 9. Alright, so we're there. And now here's what we have to do at the end. So 44 over 35 is an improper fraction. And 35 can go into 44 one time. So we add 1 to the 9, and we say 44 minus 35 because 35 times 1 is 35. So 44 minus 35 is 9. So we add our whole numbers. 9 plus 1 is 10. We keep the what we got for the answer. That's going to become the new numerator. And then we're going to put that over the old denominator. So our answer in simplest form, believe it or not, is 10 and 9/35. But that's how you convert your final answer to make it a mixed number. So I'm going to give you a second to write that down. Hopefully you can completely see it. I'm trying to switch my board around here. Alright, so I went to get my water, and now we're going to start with subtraction. And subtraction is much like addition, except for the possible advent of borrowing or regrouping. So let's start with 4 2/5 minus 1 1/4. Alright. So what's our first step, guys? We find a common denominator. And I know that the common denominator is 20, and the reason I know that is because 5 is prime. So that means 4 and 5 have no factors in common, because the only two factors of a prime number are 1 in itself, and then in this case 1 and 5. So 5 times 4 is 20, so we got to do the top by 4. 2 times 4 is 8. Same thing on the bottom. 4 times 5 is 20, and 1 times 5 is 5. So we've got a pretty straightforward problem here. So we keep our denominator, and we subtract our numerators. 8 minus 5 is 3. Then we subtract our whole numbers. 4 minus 1 is 3. So our final answer is 3 and 3/20, or 3 and 3/20 if you would prefer. So we're going to do another one, and hopefully I can make one that has borrowing in it. 2 and 1/2 minus 1 and 3/4. Alright, this one's good. So we need to find a common denominator first. So the common denominator is going to be 4, and the reason I know that is because 2 times 2 is 4, so they have 4 in common, obviously. So we're just going to bring 3/4 over, and we're going to make 1/2 into 2/4, as I'm hoping we remember. Alright, so now we still have a problem. We can go ahead and bring our denominator down, but we can't subtract 3 from 2. So we have to take 1 from the 2, and that becomes a 1. And then when we take 1, we don't just add 1 to the numerator. Instead, because in this case 1 is 4/4. So that means our new numerator would be 6, and the denominator would say 4. So it would be 6/4 minus 3/4. So 6 minus 3 is 3. And 1 minus 1 is 0. So our answer to 2 and 1/2 minus 1 and 3/4 is 3/4. And if you want to add it back in, take another look at my subtracting fractions part 1 and 2. I think I did 2 parts, and it'll let you know in there. But just in case, just for the fun of it, let's add it back in here. So 3/4 plus 1 and 3/4. Or it might be easier to do it this way. We keep our denominator. We add our numerators, 6/4, and we just add the 1 because we have nothing above it. And as you can see, that's what we got here. However, we can convert it to 2 and 2/4, which is the same thing as 2 and 1/2, which is what we started out with. 2 and 1/2. So that's how you check your work when you're subtracting fractions. Alright, So that's two examples of addition, two examples of subtraction. Now we're going to do one example each of multiplication division. Why? Because I think they're the easier operations when it comes to fractions. So, but we're going to do mixed numbers in both of them. So let's multiply 2 and 1/2 times 3 and 1/3. Alright, so I wouldn't even recommend writing that vertical, because writing it up and down, because it's not going to help you any. So the first thing you need to do is convert these. 2 times 2 is 4. 4 plus 1 is 5. So we got 5 over 2 times 3. 3 times 3 is 9. 9 plus 1 is 10. And we keep our denominator. So we multiply straight across. 5 times 10 is 50. And 2 times 3 is 6. Alright, you can either simplify this now or in just a minute. We've got to make this into a mixed number. So 6 goes on the outside of the house. 50 goes underneath. 6 goes into 50 8 times. 8 times 6 is 48. 50 minus 48 is 2. And we put that 2 over the 6. So we have 8 and 2/6. And 8 and 2/6 can reduce. This reduces by 2 on top and 2 on the bottom. 2 divided by 2 is 1. And 6 divided by 2 is 3. We bring down your 8. Now, the only real way that I say to check this, we went over this in multiplying mixed numbers, is when you multiply the whole numbers 2 and 3, you get 6. And if 6 is between 3 below and 3 above, then you have a pretty good guess of you're right. So 6 is within 3 below. It's actually 2 below. So you've got a pretty good guess that you're correct. Now, we could get into checking this, but I just think that would be a little more difficult than what it's worth. And again, if you went about your steps, then you should be pretty confident. And just to let you know, I'm making up these problems, so I don't know for 100% certainty that the answer that I'm getting is the actual answer. The reason that I feel comfortable with it is because I know the math. I know what I'm doing, and if you know what you're doing and you feel confident in what you're doing, then you've probably got the right answer. So let's take these numbers. They're easy numbers to work with. 3 and 1/3 divided by 2 and 1/2, and we're going to divide these. So we've got an added step here, but that's okay. We're going to get through, and I'm going to show you how. Man, that light is crazy on the board. Okay, so first we're going to convert them. We're going to go 3 times 3 is 9, plus 1 is 10. 10 over 3 divided by 2 times 2 is 4, plus 1 is 5. 5 over 2. Now, please don't skip steps. I've seen a lot of students that skip steps and they end up just confusing themselves. Now we're going to keep, change, flip, because we know that's the action, and then everybody's going to know how we're dividing fractions. So we keep 10 over 3. We change division to multiplication because that's the opposite. And we flip 5 over 2 to 2 over 5. Then we multiply. 10 times 2 is 20. And 3 times 5 is 15. Now we can either simplify this first or just make it mixed number. So 15 goes in 20 once. 1 times 15 is 15. So 20 minus 15 is 5. So we've got 5 over 15. However, we have to reduce that to make it a complete right answer. So we reduce it by 5 because they can both be divided by 5. Okay, 5 divided by 5 is 1, and 15 divided by 5 is 3. We bring down your 1. 1 and 1/3 is our final answer to 3 and 1/3 divided by 2 and 1/2 equals 1 and 1/3. And then we just went about the steps right there. Now I'm sorry that this is sideways. I've got a little bit of an odd setup here, but hopefully you're able to follow the videos, and I hope that you're taking notes. If not, then you can refer back to these videos whenever you need to. Until next time, I'm Mr. Beatty, and I'll see you later.